Hello, today I will introduce my work in this project as well as the process and results of security testing I conduct on the project using OWASP ZEP. In task 2, I was performing both automatic and manual security testing to identify potential vulnerabilities and propose corresponding remediation measures. In task 2, I used OWASP ZEP to conduct detailed security testing of the project. The testing process included both automatic scanning and manual testing. Throughout automatic scanning with ZEP, we detect several potential vulnerabilities. So regarding the CW1021, improper restriction of rendered UI layers or frames, the issue was detected. The nature of this vulnerability, how it could be exploited. CW1021 is a vulnerability caused by absence of X-frame options and or content security policy headers, allowing attackers to perform clickjacking attacks by embedding iframes. So to better understand this vulnerability, typical attack example, such as suppose an attacker creates a malicious website and embeds an iframe displaying the user's bank account page. The attacker can overlay a get a free gift button on the page, while in reality the user is clicking a maybe transfer funds button. So this way the user may have performed a fund transfer operation without knowing it. This type of attack is highly common, and users typically find it difficult to detect. So in the project, we verified the existence of this vulnerability through manual testing. I reviewed the project's uh, engine configuration file and found that it lacks configurations for X-frame options or context security policy headers, which match the description, issue description of CW1021. So, and then I modified the engine configuration file. Adding the X-frame option security header can effectively prevent the web page from being embedded in an iframe, thereby blocking clickjacking attacks. Then turn off survey tokens, hide the survey version information, reducing the likelihood of potential attackers exploiting known vulnerabilities. These changes significantly improve system security and reduce the risk of malicious exploitation of the project. So after completing the modification, I redeploy the project and rescan it with step to confirm that the vulnerability had successfully been fixed. So throughout the project, I have gained invaluable experience in configuration Docker containers for both front-end and back-end applications. This included setting up a MongoDB database, Mongo Express, and Nginx proxy, with all service interacting through Docker Compose in task 1. I also managed to deploy the project using Kubernetes via Minikube, which allowed for better scaling and management of containerized applications. In terms of vulnerability detection, I successfully identified several vulnerabilities using ZEP and manual testing. So these concepts will be very extremely beneficial in my future career, particularly in software development and network administration, where containerization and security are increasingly critical. Moreover, I dedicate myself to providing detailed documentation and actively participating in group discussions to ensure the project's success. I was also able to assist other team members with technical tasks when they encounter difficulties, which further enhanced the collaborative spirit of our team. So, in conclusion, during the project, I also use a variety of self-study resources to support the completion of tasks. I have used Docker community forums, one of the important resources to solve container networking issues. In task 2, I consulted the extreme options document on Mozilla, which helped me understand how to set nginx script headers to prevent clickjacking attacks. Also, um, I also watched several YouTube videos, tutorials, which help me better understand how to use Minikube to manage it and scale containers in task 1. So lastly, the artificial intelligence, such as ChatGPT, also play an important role in my learning process, especially when debugging and solving problems. Thank you very much.